Alright, so block, it's on a smooth surface, and then it hits a rough patch with a coefficient of friction of 0.2, and that's kinetic friction, which means this is the friction that affects it when it's moving. And before we do anything, we want to start with the free body diagram. And just to be clear, we're drawing a free body diagram of it on the rough patch. I should have been clearer about that, but now you know. So we have the normal force, and we have the weight force. And finally, we have a friction force that goes to the left. Next, we get the normal force acting on the box. So we'll do that right here, using Fn minus Fg equals 0. And in this case, that's going to be Fn minus 50 kilograms, 50 newtons, it's 5 kilograms times 10, equals 0. And so we are getting a normal force equal to 50 newtons. Next, we're going to go ahead and calculate the size of the frictional force opposing the motion of the box and use this to determine the acceleration. So with that in mind, we are going to use the equation for kinetic friction, since the box is in fact moving. That's going to be 0.2 times the normal force, and that will give us a 10 Newton frictional force acting on the box. Let's get the acceleration. So we have here 0, if you want to think of this as being an applied force of 0, minus F of F, force of friction, equals the mass times the acceleration, or in other words, negative 10 equals 5 times A, because 5 is the mass, and that will give us an acceleration of negative 2 meters per second squared. Let's calculate the time it takes the box to come to a stop. We'll use our kinematics formulas. So that will be V equals AT plus V naught. So 0 equals negative 2 times the time plus our initial velocity, which is 30. And that's going to give us a time of 15 seconds. Lastly, let's get the distance it travels before it stops. So we could say V squared is V naught squared plus 2A times X minus X naught. Putting in our numbers, we end up with a speed of 0. We'll square that, equals 30 squared plus 2 times negative 2 times X minus 0. Great. Finally, we're going to end up getting 900 divided by 4 is our distance. So when we actually work that out, we will get 225 meters. All right, so that's it for the non-honor students. Honors physics, I've got a couple more videos. Let's see, how many more do we got to do? We got number 12 and number 13. 12, 13, and 14, excellent. So we will take a look at those in the next video.